Good day. So we've reached the last section of the 2020 paper, January. 53 to 60 would be geometry and trigonometry, which would include translations as well, and transformations, which is translations, reflections, rotation, enlargements, bearings, and circle geometry, which is the section 2 topic. So what we're going to look at first, and again, a whole set of questions repeat from the 2018 paper, which makes it easier for me just to show from the 2018 paper. So the first one is a translation, which is one of the 4 main transformations that you have. So a translation means you're just sliding it from one place to the next, kind of like how you'll move a fridge magnet on your fridge to a different point. We're just sliding it, so all points moving by the same amount. So here, how it works is A with no number on it means the original, and if it have a little 1 on it, A prime means that's where we move it to, or what we did to it, B prime, that's where it end up. So you're moving from A to A prime, meaning we're going from 2, 5, we tend to write it top and bottom, going to end up at 4, 6. Same thing here, 5, 7, going to end up at 7, 8. So what really happening to the X number, it increases by 2, and the Y number increased by 1. The X number increased by 2, and to be the same thing for both of them, the Y number increased by 1. So both of them move by X is 2, Y is 1, so that's why the answer was 2, 1. Number 54, this was number 54 from the 2020 paper. It was number 52 on the January 2018 paper. I'm just using it because the diagram is drawn already. And this was one of the basic geometry rules. Between the parallel lines, we have the transversal third line cutting those parallel lines. And this is really the Z-shape rule, which we call alternate angles, and those 2 values going to be equal, right? Alternate angles. Next one, number 55, was same number 55 on the paper. It was a bearings question, and for bearings you need to know your compass direction. North and south easy, but once I write it as we means it's in the correct direction, west and east. So a ship starting off at a point A and going east, so I go in this direction 8 kilometers from a starting point A to B. And once I reach B, I go in north to C, 6 kilometers up. The only one that looking like that is C, 8 kilometers to the east, 6 kilometers up. Number 56, more transformations in each of the following diagrams. OA prime is the image of OA, right? So OA is the original, OA prime is where it's going to end up after we do something to it. And what we want to see specifically in this one is a reflection, but somewhere specific in the y-axis. So looking at the first diagram, is a reflection, yes, because you can see it reflected half and half here, but this is a reflection in the x-axis, so there's no answer. That's a reflection, but yes, it's in the x-axis. B is a reflection in the y-axis, so this is the y-axis here, meaning the y-axis acting as a mirror, and you can see half and half on either side, so my answer is B. Let me see what C is. C is not a reflection, it's not a translation either. C is a rotation, and you can see it rotated, and they tried to draw it exact. It actually rotated 90 degrees. And D could either be a reflection in the line y equal x, because it's reflected on either side, y equal minus x, or a rotation at 180 degrees, because I turned this 180 degrees. But those are the different analyses I could do with the diagrams that we have for the transformation. This would be the specific one that we was looking at though. So let's look at some more. Number 57, in the triangle ABC, angle A equal x degrees, angle B equal 2x degrees, and I want what is the size of angle C. So I'm going to draw a diagram just to show you a little better. So we have triangle ABC, angle A this A, meaning the angle by A is x degrees, the angle by B is 2x degrees, and the angle by C is what I want to figure out, right? What's the angle C? We should know by now that in a triangle adds up to 180 degrees, meaning if I was to add x degrees plus 2x degrees plus the unknown, angle C, I could call it angle C, I could call it the unknown. I'm supposed to get what a triangle is supposed to add up to, which is 180 degrees. I'm going to clean it up a little bit. Again, x and 1x mean the same thing, so 1x plus 2x. 3x plus the unknown angle C is 180 degrees. So if I want the unknown angle C, I carry across the 3x, it'll just be 180 degrees minus 3x, which is option D. Number 58 is our next question from the January 2020 paper. Number 4 here I have it. It was number 58 on that paper as well. Enlargement, so in other words, our next transformation. So the term is enlargement, which usually means it gets bigger, and you could see they want the scale factor, which really means how much times bigger it gets. So this is the original, this is the image because it have the little one on it. How much times bigger this gets? So there are different ways you could do it. I watch a length and then compare it to the same length on the next diagram. So this is 2 units because it went from 0 to 2. This went from 0 to 4. So to go from 2 to 4, you could realize it double in size, which means times 2. Or we could have drawn it from the origin because they say the center was here. So when I shoot it out from the origin, and I shoot this out from the origin, and I shoot this out from the origin. The only one we could really read though, because that's kind of like shining a light on a projector item for a projector, and it kind of projected on the wall there. That's how it get bigger, usually, just like what they do in cinemas. We could watch the distance. So this distance was 2, and then the distance doubled to 4. This distance would have doubled, this distance would have doubled. However you do it, it would have doubled, and that will be the scale factor, how much times bigger it is. Next one, number 59. We have similar triangles, and they have different rules for similar triangles. Here we have all triangles are the same. It's not the exact same triangle, but all triangles are the same. Here's 31, 59, here's 90. So that means the triangle's related. So if this length is 6 cm and we find out this length is 3 cm, that means since the triangle is similar, then this have a relation to this, which is the angle, the length they want to find, by the way, MO. So they want MO, but obviously MO going to be related to AC, and the relationship is this relationship. To go from 6 to 3, that means it was cut in half. So that means to go from here to here, we also have to cut it in half to keep the ratio of the diagrams the same. So half of 6 is 3, so half of $7 is $3.50. So that would be my answer. Last one, number 60 is the next one from the January 2018 paper again. It was number 59 on the 2018 paper. So they have a diagram and they want which one of these trigonometric ratios will give them a 4/8. So again we have, and this on the formula sheet. So again, if I turn to the front of the booklets, we have our formula sheet, and I would discuss that already with all you. The bottom half have my formulas for trigonometry. Well, look, the ones on top, they're trigonometric ratios, and the other is really for the harder ones in paper 2, right? The sine rule, cosine rule. So back to this question here. Sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tan theta is opposite over adjacent. And with respect to the angles, we name the sides. So I'm just going to show you, if I was to choose y as the angle, then this is going to be the opposite side here. This is going to be the adjacent side because it's touching. That's what adjacent means. And the hypotenuse is always the hypotenuse. So to get 4/8, that means I need A and H, which means cosine y. But when I look at the answers, I'm not seeing cosine y, meaning they probably didn't use y. So I'm going to check when I make x the main angle, because they didn't say which one the main angle is, right? They had both angles there on purpose. So if I was to make x the main angle, that means this now opposite to x, this side opposite to x. So he's going to become the opposite now. He is still the hypotenuse, but since he touching now, he's going to be the adjacent. And again, to get 4/8 this time will be opposite over hypotenuse. Opposite over hypotenuse giving me the 4/8, meaning sine x will give me opposite over hypotenuse. So that's how my answer ended up being A. Sine x in this case, which is the same thing as cos y. They didn't have cos y as an option though, but cos y would also be correct. That wasn't an option that you had here though. So something just to keep in mind. Again, just like the last video, I didn't go through all the questions because my colleague would work out almost all on her page, and I'll just put the links in the description of this video below. Of note is no questions on the 2020 January paper came on circle geometry, so that's something you should really look at on her videos. And something else to keep in mind, I would have never analyzed a multiple choice paper like this, but 28 questions on the January 2018 paper repeated in the 2020 paper, and that's just from one paper. Almost half the questions would have repeated. So that's why doing the past paper is really helpful, because you never know how much questions from a particular past paper are going to repeat. This was just from one past paper and almost half repeated. So keep that in mind. The video is going to finish here though, because we reached the end of this. All the best in all your exams, okay?